orthogonal spheres. We know angle between two spheres is defined as the angle between the tangent planes drawn to the spheres at their common point. Okay, so radii, which means radii at their common point, is going to be perpendicular to the tangent planes at these points. We have already proved this, that radii of a circle is perpendicular to the tangent plane at the point of contact of the tangent plane. So the angle between the spheres at the common point is going to be equal to the angle between the radii of the spheres at the common point. Okay, so here this is the picture. This is the center 1, center 2. This is one point of contact, this is another point of contact. There might be many more points of contact. Because remember, even though I have drawn a circle, it is a sphere we are talking of. Now, remember, if two spheres cut orthogonally, which basically means at an angle of 90 degree, the tangent line drawn to one sphere at the common point will pass through the center of the other sphere, and the other way round also, vice versa. So therefore, if you look at this diagram again, this is going to be 90 degree in case of orthogonal sphere, and this is going to be 90 degree. And these two angles are going to be equal. Remember, angle P is going to be angle Q. Why? Because triangle PC1C2 is congruent to triangle QC1C2. And why that congruency? Because you have a hypotenuse common, right? Hypotenuse is common, so basically RHS. So an angle and the hypotenuse are equal, so which means that these two triangles are congruent. So which means we can apply Pythagoras theorem, right? So which means square of the distance between the centers is going to be equal to the sum of the squares of the radii. So in other words, we can say C1 C2 square is equal to R1 square plus R2 square. Okay, now let's actually try to figure out the condition for two spheres to be orthogonal. So let's say we have two spheres, S1 equal to x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 equal to 0. Let's say we have the second sphere, x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2z plus d2 equal to 0. Now we are going to look at the condition for S1 to be perpendicular to or orthogonal to S2. For S1, center would be minus u1 minus v1 minus w1, and radius would be square root of u1 square plus v1 square plus w1 square minus d. Similarly, for S2, center is minus u2 minus v2 minus w2. The radius is going to be u2 square plus v2 square plus w2 square minus d2. This is actually d1. Okay. Remember, c1 c2 square is equal to r1 square plus r2 square. We saw that here. Okay. So now let's figure out c1 c2, the distance between c1 and c2. That distance would be u2 minus u1 square plus v2 minus v1 square plus w2 minus w1 square is equal to square of r1 square. Square of r1 square would be, just remove the square root. So u1 square plus v1 square plus w1 square plus minus d1 plus u2 square plus v2 square plus w2 square minus d2. Okay, which implies, let's open these brackets, u2 square minus 2u1 u2 plus u1 square plus v2 square minus 2v1 v2 plus v1 square plus w2 square minus 2w1 w2 plus w1 square is equal to u1 square plus v1 square plus w1 square minus d1 plus u square plus u2 square v2 square plus w2 square minus d2. So u2 square u2 square, u1 square u1 square, v2 square v2 square, v1 square v1 square. Okay, so what we are left with is minus 2u1 u2 minus 2v1 v2 minus 2w1 w2 is equal to minus d1 minus d2. Let's multiply the entire thing with minus 1. So we get 2u1 u2 plus 2v1 v2 plus 2w1 w2 equal to d1 plus d2. So this is the condition for two spheres to be orthogonal. So what this means is, if you are given equations of the two spheres, just check, substitute these values and check whether they are equal. If they are equal, that means they are orthogonal. So that is orthogonal spheres. That's it. Bye for now.